Hello everybody. I wanted to take a moment to go through domain. We went through this in Unit 1 and we've revisited it in Unit 2, but I wanted to clear up where we're at. There are two types of expressions that we talked about in Unit 1 that specifically have restrictions on them. And in Unit 2, when we're talking about it, we have three types of expressions that we're looking for domains on, or expressions as they're used in functions. We have polynomials, we have rational functions or rational expressions, and we have radical functions or radical expressions. Now, we're going to look for the domain for each of them. The thing to remember for domain is that the domain is always going to be all real numbers except what? Except my exceptions. Except the exceptions. And I put it in brackets because the exceptions are different for every kind. The exceptions are the things that cannot be allowed to be substituted in for the variable. When we were dealing with rational numbers, we said our exceptions are whatever made the denominator equal to 0. So we said, let's take an example, something such as 1 over x minus 5, something simple. When is the denominator 0? Well, the denominator is 0 when this entire expression in the denominator, x minus 5, equals 0. The entire denominator is 0, and that's when it's not allowed. So I'm going to rewrite this as x minus 5 cannot equal 0, because we want to show that it can't be that. So if I add 5 to both sides, then I get x is not equal to 5. And that makes sense. 5 minus 5 is 0, 1 over 0 is undefined. So these are the restrictions, but we don't care so much about the restrictions. We don't care what it's not, we care what it is. So we plotted this on a line, and we said, okay, here at 5, we have an open circle there, and we said everything else is shaded. And then we looked at this line and we decided what is the shaded area? The domain is what's allowed. It's all real numbers except what it can't be. So I rewrite this in interval notation. It starts at negative infinity, continues to 5, comma representing the shaded area if you think of it that way. There's a gap, so gaps are taped together with a union. And then it starts again at 5, not including the point, and continues on to infinity. That's my interval notation. If I chose to write it in set notation, I'd say it's the set of x, or the set of x in real numbers. Remember, if it's not written, you assume it's real numbers. The set of x such that x is less than 5, or x is greater than 5. And then we have our domain. The exceptions for polynomials are easy. What are the exceptions for a polynomial? Well, there are none. There's nothing that I can put, no real number that I can put into a polynomial that will give me an invalid answer. So the domain is all real numbers except the exceptions, and since there are no exceptions, the domain is all real numbers. Or in interval notation, that. Always, always, always. Radicals. What are the exceptions for radicals? Well, if you have a radical expression, what can't go inside a radical expression? If we're dealing with real numbers, then the radicand has to be greater than or equal to 0. It cannot be less than 0. So I guess the exception then, I would not want to write it the radicand greater than or equal to 0 because that's not the exception. I would say the exception would be that the radicand cannot be less than 0. Potato, potato. I'm just trying to be precise in my words. So what is the domain? Well, what's not less than? Not less than includes greater than, but also 0. So let's ask ourselves, what's the domain of a simple function like x minus 5? Square root of x minus 5. The radicand here is x minus 5, so I know that x minus 5 cannot be less than 0, so it has to be either greater than or equal to 0. If I add 5 to both sides, then I see that x has to be greater than or equal to 5. Plot that on a line. Closed circle to show that it can be equal to 5. And then shaded after that to show that it can be greater. Now, I could rewrite it. I'll just slap a set notation on it and call it good. Or if I prefer to write it in interval, then I would write it -5 to infinity, including -5. Now they get a bit more complicated than this, only as far as the math goes. So if I had something like, what is the domain of, well, I don't know, the square root of 4 minus x squared? Well, you would still set the radicand greater than or equal to 0, but now the math is more complicated, and you would wind up with -2 less than or equal to x less than or equal to 2. The math is beyond the scope of what I'm doing right now. Suffice it to say, the domain is the set of x that meet that condition, or in interval notation, that. And then we dealt with more complicated ones for rationals, where you had something like that required you to factor the denominator. So the restrictions here, x cannot be what? X cannot be 5, because 25 minus 30 is -5 plus 5 is 0. And it can't be 1, because 1 minus 6 is -5 plus 5 is 0. So if I drew a line, here's my 1, here's my 5, cannot be 1, cannot be 5. Shade in everything else. It's all real numbers except. Interval notation would be -infinity to 1, union 1 to 5, union 5 to infinity, not including any points. If I wrote it in set notation, the set of x such that x is less than 1, or 1 less than x less than 5, or x greater than 5. I hope this helps. Keep this in mind to refresh your memory, because these situations are going to come up again and again and again, especially when we get to Unit 3. Okay? Hope this helped. Have a good night.